Hi, we are here to introduce our paper titled Towards Robust and Smooth 3D Multi-Person Pose Animation from Monocular Videos in the Wild. This paper focuses on the topic of 3D multi-person pose estimation. We are all affiliated with Seoul National University in South Korea. Here is the index. Our work mainly addresses the three most critical challenges in this problem: generalizability, occlusions, and jittering. To tackle the first and second challenges, we consider data augmentation and sequence-to-sequence modeling as the most natural and effective solutions. Our data augmentation methods enable us to generate an unlimited range of camera angles and distances, while sequence-to-sequence modeling helps the model disentangle occluded individuals by providing sequential temporal information all at once. Additionally, we propose a simple but effective spherical volumetric person model to simulate occlusion among people while augmenting the training data. For the third challenge, jittering, sequence-to-sequence modeling proves beneficial once again, as it naturally understands temporal dynamics and can be further improved by an explicit loss designed for this purpose. This motivation also extends to our model selection within the 2D to 3D lifting paradigm. This is our model. The name Potter 3D stands for Pose Transformer for 3D. We have chosen to operate Potter 3D within the 2D to 3D lifting paradigm, not the end-to-end one. This approach involves initially detecting 2D body key points using an off-the-shelf model and then lifting them into 3D space. By solely focusing on the dynamics of a few key points, we can significantly reduce the cost, then can generate rich augmented data sets and enlarge temporal residual fields. After pre-processing, the joints are embedded and fed into the repeated three different types of transformers, where each of them is designed to model a specific relationship between different body key points. SPST and SJTT for modeling spatial and temporal relationships, and IPST for interpersonal relationships, which is also related to occlusions. Here, we simultaneously estimate the absolute position of the root joint and the relative positions of others. This is why we refer our lifting module with the keyword unified. Finally, we apply two loss functions, MPJP loss for accuracy and MPJV loss for smoothness. As mentioned, our method allows infinite data augmentation. Here we propose an explicit way to thoroughly cover the data space and generate reasonable and plausible augmentations. We achieved this by applying two rigid transformations, translation and rotation, to each individual and the ground plane, resulting in four types of augmentations. To reflect occlusion into our augmentation, we propose a simple but effective spherical volumetric person model which represents a human as a group of 3D spheres centered at each key point. We judge occlusion with distance between each sphere pairs, then add noise to or drop out this occluded sphere to mimic the significant detection failures typically caused by occlusions in off-the-shelf 2D pose estimation models. This approach is simpler and computationally more efficient than existing complex models, such as the Cylinder Man model or SMPL. We record SOTA on the two most famous benchmarks, MUPO-TS3D and CMU Panoptic. Quantitative result gap becomes more larger in the sub-dataset where more severe occlusions occur. A substantial gap exists in MPJV metric, which simply represents smoothness. We particularly want to highlight the significant difference observed in qualitative aspect. Our approach consistently produces much more robust and smooth results. The effectiveness of our method is further proved through elaborated ablation studies. For more in-depth information, please refer to our paper. Potter 3D also demonstrates remarkable performance in a wide range of real-world videos. We anticipate that it will be utilized for commercial applications in near future. Thank you for listening.